Jet engine technology is widely considered the holy grail of aviation tech. Very few countries have it and everyone wants it, which is why the US decision to transfer key engine technology manufactured by General Electric to India will be a landmark deal, which will be signed by the Prime Minister during his state visit to the United States. I have this deep dive into why manufacturing these engines in India will be transformational for Indian airspace. Jet engine technology, widely considered the holy grail of civil and military aviation. This is the General Electric GE F414 engine, a cutting-edge jet engine that powers the F-A-18 Hornet, the US Navy's go-to fighter. This engine may now be produced by General Electric in India. In a multi-billion-dollar deal with Hindustan Aeronautics, with reports suggesting that America is willing to transfer key technology worth up to 80% of the value of the deal. It would power the LCA Mark II, an advanced variant of the Made in India Tejas fighter that you see here. The United States has never allowed the transfer of this level of technology to anyone. State-of-the-art jet engines include components which are deeply intellectual property rights protected, with manufacturing processes that are top secret. The technology that India may get includes coating and machining of single crystal turbine blades. What exactly are we talking about? Consider this. Manufacturing components of jet engine turbines has always been a massive engineering challenge through the history of aviation. Jet turbines need to retain their shape, their strength and their efficiency at temperatures up to 2000 degrees centigrade. Metal alloys used in older jet engines using conventional manufacturing techniques failed at the highest temperatures. They lost their thermal efficiency, which is why a handful of companies began to develop what they call single crystal turbine airfoils. Through profound chemical engineering of superalloys, single crystal turbine airfoils are able to achieve 3 times more engine life protection against corrosion resistance. Far lower overall weight. It's a lighter engine. A higher melting point temperature. This is absolutely critical. And massive engine life. Much more than usual, up to 25,000 hours before an overhaul takes place. For India, the deal will mean that GE will open shop in India in partnership with HAL at a new plant to introduce the manufacturing processes required to build not just single crystal turbine blades, but also other key components including laser drilling for combustion, machining of powder metallurgy, and the manufacture of compression discs and blades. The GE 414 IN6 engine, when it's built in India, will power not just India's indigenous Tejas Mark II fighter, but also the futuristic AMCA, or Advanced Medium Combat Aircraft, a stealth fighter. For the Indian Air Force, this will mean reliable and long-lasting jet engines. Russian engines in the past frequently needed an overhaul at a few hundred hours. Now you have engines which can be overhauled after several thousand hours. Engines which are lighter, more powerful, much more fuel efficient, and with the potential to be upgraded for future use. The benefits of all of this will be transformational for the Indian Armed Forces. Vishnu Shom for NDTV. Well, another key deal that the Prime Minister is expected to sign during his visit to the United States is a $3.1 billion agreement for the direct purchase of 31 MQ-9B drones from the American company General Atomics. These are extremely advanced and upgraded variants of the well-known American Predator drones and have the ability to carry weapons as well. But it's the sensors on board that make them formidable assets, particularly against China. When this drone enters service with the Indian Armed Forces, it will bring with it an unparalleled reconnaissance capability. It's called the MQ-9B Sea Guardian. It can fly non-stop for over 30 hours. It's equipped with a host of sensors which will allow our armed forces to get real-time awareness of developments in a particular area, day or night. So for example, a variant of the Sea Guardian can be deployed along the Ladakh frontier where, from a safe distance from enemy missiles, it can provide non-stop sensor data of a build-up of Chinese forces. While deployed at vast distances out at sea, it can keep an eye, for example, on Chinese or Pakistani fleet movements from a safe distance, out of the range of the surface-to-air missiles of the ships. The Sea Guardian has a mission radius of more than 2,000 kilometers. It can fly for 30 hours non-stop. It can be equipped with sonar buoys, which are sensors which detect submarines. It can detect enemy ships and pass off data to friendly ships and submarines, which can then engage these targets. The deal for the MQ-9B has been in the works for years. It will be worth more than $3 billion and would likely include 31 drones for India, 15 for the Navy, 8 for the Air Force, 8 for the Indian Army. India's acquisition of these drones comes at a time when China has positioned its most advanced soaring Dragon drones along the frontier with India, details of which were broadcast on NDTV in a December report. China is now the world's leader in drone development after the United States. With India's acquisition of state-of-the-art MQ-9B drones, the technology imbalance which presently exists will be corrected to an extent. Vishnu Shom for NDTV. Alright, so essentially there are two very important deals, one with drones and one with jet engines, which India is actually going to be looking at. Let's just talk a little bit more about the jet engine deal. It is with General Electric, not to be mistaken with General Atomics, which is providing the drones. This is General Electric, and they'll be setting up a plant over here in India. It will be a process of about 3 years or so before that technology transfer happens in full. The technology transfer itself will be approximately 80% of the value of the overall deal. So that's the engine that we're actually talking about, the animation that you're looking at. It's called the GE414. It is state-of-the-art. It powers the American FA-18 fighter, which is their go-to fighter for operations on aircraft carriers. And once it's built in India, it means that Indian workers would have exposure to advanced metallurgy, the ability to develop those or to manufacture single crystal turbine aerofoils, and that's the essential technology that is important. This is an advanced use of super alloys which ensures that those jet engines can operate at temperatures of 2000 degrees centigrade. The higher the temperature that they can operate in, the higher the thermal efficiency. It needs to be able to do this safely over a period of time, be reliable as well, lightweight as well, and far more fuel efficient. That's where jet engine technology is getting at.